questions that I've chosen for you are the following, if you want to make a note of this. So we're going to go through question 20 all the way to, where are we? Question number 13. Okay, so we're going to cover all of that, and that covers a good range of grade 7+. And if time permits, we'll also go through questions 12, 9, and 7. And of course, I will try to do the rest of the paper, if it's done in good time. Please know I will look at the chat as we go along every so often. So if there's anything that you don't quite understand, please do let me know, and I will try my best to offer you alternative explanations. Okay? Right, so let's begin. Let's start with question number 13 first and foremost. So here we go. Here we go. So if you want to make a note of this, so as we go along, what I ask you to do is do your own solutions step by step, write down the questions, and I'll proceed to explain things as well. Okay? So we have this question where we have to show that 6 plus this bracket, x plus 5, divided by another fraction, x squared plus 3x minus 10, all over x minus 1 simplifies to the following, where a, b, and c, and d are integers. All right, so how do we begin something like this? Where we are going to look at rectifying, or we are going to look at this fraction. And what we are going to do is we can do one of two things. We can either look at the fraction and simplify the quadratic at the top, or we can, you see this division sign here, we can flip the second fraction, we can flip the fraction upside down and put a multiply sign there. So we can have 6 plus x plus 5, this one, and then we can put a times sign here, and then x minus 1 over x squared plus 3x minus 10. Okay, sorry, that didn't come out very nicely, so let's do that one again. And then we can close the bracket. So that's step number 1. Now this question carries 4 marks, so I will try to tell you where the marks are as we go along, where you can pick the marks up. So if you're a student who is sort of middle ability, and that's what I'll be aiming more so at, then you have an opportunity when you see these hard questions to pick up as many marks as possible. So you don't even have to answer the entire question. Okay? So what we're going to do is we are going to factorize that quadratic. All right, so that's 6 plus. And if there's something that you don't understand, there are several videos for some of these topics on my channel. So I will show you at some point where you can go and how you can search for these videos. So if you need to know how to factorize a quadratic, there are videos on the channel that you can go to if you don't quite understand how to do that yet. Okay? Right, so we have x minus 1 on the top, and then we know that this is a quadratic that will have double brackets. Now, we'll have x here, and we'll have x here. Now, we want to get 10. So we want something that multiplies from here and here to give us minus 10. And also something that adds to give plus 3x. So we will have minus 2 here and 5 here. Now, if you look at this, that will give you exactly all of that. And then, if you look at this, we can combine them together. So we can put this and this together. Okay? So, what does that look like? That will be x plus 5, and then x minus 1, and then x minus 2, and x plus 5. Now, before going further, you can see that we have 2 brackets which are exactly the same. And we can cancel out these brackets. Oops, I'm getting the colors wrong here. We can cancel out these brackets. So x plus 5 and x plus 5 will cancel out. That leaves us with x minus 1 over x minus 2. And then we have our 6 outside. Following on from that, we remember we have to go back to the question, and this is how we want it to look. Okay? So what will we do next? Well, you see, we have to find a way of introducing the 6 with this. Now we have 6 plus this fraction. So what we need to do is make 6 into a fraction. And you can do that easily by doing 6 over 1. So you can have 6 over 1 plus x minus 1 over x minus 2. Now, in order to add fractions, and of course there's a video for that on the channel if you need to go and have a look at that. In order to add two fractions together, you need to have the same denominators. You see, 6 at the moment has a denominator of 1, and the second fraction has a denominator of x minus 2. We can make them have the same denominator by multiplying the 6 over 1 with x minus 2. So that would look like this: 6x minus 2 over x minus 2. And in the second fraction, we can just leave this as it is. So we can have just x minus 1 bracket. Now you'll notice I put this over one fraction now, because when I did the cross multiplying, that's what we can do. We can have just one denominator. Okay. Now we'll just simplify this. So we'll expand the brackets out like here, and then we'll get 6x minus 12 plus x minus 1 all over x minus 2. And then we can collect all of the like terms. So we have 6x plus 1x, giving us 7x, and we have minus 12 minus 1, giving us minus 13, all over x minus 2. And we have our final answer right here. Now if you compare this to the question that we have been given, we have ax minus b over cx minus d. So therefore our a value will be 7, our b value would be 13, our c value, now what is the value coefficient of c, or the value of c? It's whatever's in front of the x. Now there's nothing in front of the x, but whenever in algebra we have nothing in front of a letter, then we say that it is 1. And then we have d as 2. Now you didn't have to list a, b, c and d, but it's just nice in your head to know what those values were. And that's the solution. Hopefully you understood that. We'll now proceed to the next question, which is question number 14. I will quickly have a look at the chat before I do that. So if there's any questions that you have, I can take anything and answer it. Okay. Okay. Sorry, I thought someone said that you lost me for a second. Hopefully you can see me again. All right, so let's move on to the question number 14. I'll just zoom out a little bit here. Hopefully I'm still here. Everyone can see. Thank you, Zakia. Hope you enjoyed that. All right, so we move on to question number 14 now. A car moves from rest. The graph below gives information about the speed v meters per second of the car t seconds after it moves. Calculate an estimate of the gradient of the graph at t equals 15. Now this recently came into the curriculum, so this is something that is quite new, and so many of you may not be quite so familiar. It might not be in your old in the textbooks that you're using unless your school has replaced them. Okay. Now the questions, it's not very difficult at all. This question is borrowed from the A-level spec, although the A-level does have some different things about it. Now I need to find out how I can get a straight edge or a straight line on my software that I'm using. So let me see if I can find one. Nope. Okay. Right. So let's have a read of part A. Calculate an estimate of the gradient of the graph at t equals 15. So if you have a look at this, this is t equals 15 right here. Okay, right there. So at this point here, we want to find the gradient. Now the gradient for a speed and time graph is simply the acceleration or the rate of change. Okay, so in order to find the gradient of a curve, like this is a curve you see, okay, we need to draw a straight line at this point right there. Okay, so let me see if I can use my ruler here and do this. So here we go. Right, now I've drawn a line there. Now your line, it may be a little bit bigger than this or a little bit smaller than this. It doesn't really matter as long as it is on this point and you're trying to make sort of like a tangent to this point right there. Okay. In fact, what I might do with my line is just make it a little bit bigger, so in case I need to have more of a bigger reach. Okay, so right there. Now what I want to do is I want to make a triangle underneath here so that I can find the gradient, and I am looking for whole squares in order to do this. Now you can look here, right there, so you can go across here, and I think right here in the corners of the boxes I have drawn a nice triangle. And you can have a smaller triangle or a bigger triangle, but the important thing is that you go to these corners right there. Okay, you cover a whole box each time, a whole box going up and a whole box going across. Okay, and you just calculate what the distance is. So from here to here, we go from this value here and this value, which this value here is we've just counted 5, so half of that is 7.5, and all the way up. Hopefully we are back again. I'm really sorry. I did notice that some of you said there was a glitch. Okay. I don't know how much of that explanation you caught, but as I was explaining it, there was a glitch in the middle, so I do apologize for that. I will continue, and hopefully it doesn't glitch anymore as we go forward. But I will keep an eye on the screen in front of me so that if there is something, then I will stop and try to get you back on again. All right. So if you read on to part 2, it says describe what your answers to part I represent. So what is this representing? The gradient that we have found, what is it representing? So we know that earlier on I mentioned that the gradient for a speed and time graph is the acceleration. So an answer that you will write, that you will likely write in here is acceleration. This is what it represents. You can also say something like the rate of change, but this is enough for the 1 mark. Okay. Right. If we continue, part B, it says work out an estimate for the distance the car travels in the first 20 seconds of its journey. Use 4 equal strips. So this is very, very important here. 4 equal strips to calculate this. Okay. So if we go back to our graph, all right, now I'm going to rub off everything else because this is just going to get in the way. So let's get rid of all of that. Okay. Right, so the first 20 seconds. So 20 seconds is right here. So we want to know the speed of the car, or the distance that the car travels. Sorry, not the speed. We want to know the distance that the car travels in the first 20 seconds. Now, the area underneath a speed and time graph, the area, okay, it represents the distance. So what you want to do is calculate the area of this zone. Now the questions mentioned that you have to have 4 equal strips. Okay, so we will draw 4 shapes underneath this area. All right, so let's do this. Let's start in equal steps. So remember, it's 20, okay, going from 0 to 20. So if we break that up, that gives us something for 5, 10, and 15. So let's draw these lines in right there, and we will draw a trapezium. And then we'll do the same here. And try to do this with a ruler so that you have good edges, right there. And this last one is a triangle. So there we have our 4 shapes with equal width, each of them. Okay. Now what do we have? We have 3 trapeziums and 1 triangle. Now if I draw this out separately, we have a triangle there, we have a trapezium. I'm not going to draw this entire size that is represented on the graph, so I'll just draw like that. Okay. And the area of each of these will be found individually. Now the area of a triangle is base times height divided by 2, and the area of a trapezium are the parallel sides. You add the two parallel sides together, so A plus B, times by the height and then divided by 2. Okay, so these are very important formulas that you need to know to calculate the areas of these shapes. Okay, just reading if there's any glitches. Okay, all right, so let's continue. Right, so each of these, the width is 5 each time. Okay, we just need to calculate the heights. Okay, so for the triangle, the height is right there. So we want to know what is this value right there. And you can make this approximation, or you can try to calculate it as well. Obviously, you will calculate and then approximate if you need to, because your lines, depending on where they are, will tell you what it is. Okay, so there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 squares as we go across. Okay, so if we use every 2 squares as 1, 2, 3, 4. Okay, so as you can see, it's roughly 4. The height of this is 4, so this is going to be 4. And if you go across on the second height right there, okay, you get roughly around, what is it, 11, 12. You get 12 right there. Okay, and if you go across to the next one, okay, that's halfway in the middle, so that would be 17.5. So that's 17.5. And the final one is easy, it's 20. Okay, so now we'll proceed to calculate the areas. I hope you can just be patient while I get there. All right, hopefully we are back again. We are back again. Okay, I do apologize, guys. Next time I promise this will be better. I did arrange this in the last few days, so I was just familiarizing myself with the software that I am going to be using. So if you know any better software that I could use to deliver lessons like this, please do let me know in the comment section, or just drop me a message on one of my various social medias platforms. Okay, right, so let's continue. We're going to find the area of this triangle right there. So the area of a triangle is base times height, so we're going to have 5 times 4 and then divide that by 2, that's 1. And then the area of the first trapezium is going to be, we also need this, so this is 4, this is going to be 12, and this is going to be 17.5 because they share the same sides. Okay, so we have 4 plus 12 times by the 5, which is the height, divide that by 2, that's our second one. And then we're going to have our the third shape and the second trapezium, which is going to be 12 plus 17.5 times by 5, divide by 2. And then the final trapezium, which is going to be 17.5 plus 20 times by 5, and then divide that by 2. And we will now calculate the values of each of these areas. Okay, so if you can go and do that calculation. I'll just do mine. So 5 times 4 divided by 2, we get 10 for this one. 4 plus 12 times by 5 divided by 2, we get 40 for this one. And then we have 12.5 plus 17.5 times by 5, divide that by 2, we get 75. And then the final one, 17.5 plus 20 times by 5, divide by 2, we get 93.75. And now we will just add all of those up. So we get 93.75 plus 75 plus 40 plus 10, giving us a total of 218.75. Now your answer may slightly vary from this, and it's okay. So if you don't get exactly 218.75, that is completely okay. The examiner in the mark scheme does allow a range, okay, as long as it's close to that figure. I don't know what that range is. It could be something like 215 to 220 or something like that, okay, or 25. All right, so I believe this question is now complete. I'll just quickly read the chat. If there's any questions on there. Okay, someone suggested use OBS or use Twitch. I did look into that, and I hope to look into that for the next one soon. Okay. Adilmia, sir, do you know how much it goes up by? I can have a quick look. I've got the mark scheme somewhere here. Hold on a second. I'll just confirm that. The mark scheme allows an answer in the range 215 to 225, as long as you have the correct working out. So that's what the mark scheme allows. Hopefully that answered your question. Okay. All right. So if we now move on to question number 15, making M the subject of this formula. Okay. Now, I have a video on this, so if you do need further support, haven't seen my solution, if you still need further support, then please go over to the channel and you can find a video for making something the subject of a formula. All right, so we want to make M the subject. So where is M at the moment? You see M is here and M is here, and currently F is the subject. Okay, so we want to get rid of this denominator right here by multiplying on the other side with the F. So we have F bracket M minus 1 is equal to 3M plus 4. Then we'll expand the bracket out. So we get F times M, so Fm, and then F times minus 1, which is minus F. And on the other side, we'll leave this as it is. The next step would be to get both M's onto one side. Currently, we have M's here and we have M's here. So we want to make them go over to the same side. You could choose to bring this over here, or you could bring this one over there. It doesn't matter which way around you do it. Okay, so let's bring the 3M over to the other side. So we are going to bring this plus 3M over to this side. So on the other side, it will become a minus. So you end up getting Fm minus 3M. And on the other side, you could take this minus F with the 4, and you will have 4 plus F. Remember, this sign will become a positive on the other side. Okay, so you have that. Next, you'll factorize the M out. So you'll take the M, and then you'll have a bracket. And then you put an F in there, and then minus 3, and equal to 4 plus F. The final step is to get rid of this bracket by dividing over to the other side. So you have M is equal to 4 plus F all over F minus 3. And now you have M on its own, and you have made M the subject of the formula. Okay. Right. Hopefully that made sense, and we can now move on to question number 16. Okay, so we have a straight line L has the equation 3y is equal to 4x plus 7. The point A has the coordinates 3 minus 5. And we want to find an equation of the straight line that is perpendicular to L and passes through A. So many of you, in case you haven't done topics like this yet, a straight line is this, and the equation of a straight line is y is equal to mx plus c, where the m represents the gradient and the c represents the y-intercept, where it cuts the y-axis. Sorry, that didn't go in there. Okay, so we are going to be using this formula, and we are going to apply it to this question. Now, the second thing you need to know is the meaning of perpendicular. Perpendicular is when two lines, they meet each other, and they create a right angle between them. So right here. So if you have the gradient of this one as m1, then this one's gradient, m2, will be minus 1 over the other one's gradient. Okay. So with this, we will now go and answer this question. Let's get rid of that. Okay, so what do we have? We have this equation of line L. So the first thing we are going to do is make this into the form y is equal to mx plus c. So we can see clearly what the gradient is. Okay, now 3y is equal to 4x plus 7, so therefore we'll get rid of the 3 next to the y by dividing everything by 3. So we have y is equal to 4 over 3x plus 7 over 3. Now can you see that we can see the gradient quite clearly? The gradient is 4 over 3. So if we write this down now, the gradient of line L, or M1 we're going to call it, is 4 over 3. So therefore the line that is perpendicular to that is going to be minus 1 over 4 over 3. And if you rearrange that, you get minus 3 over 4. So the equation that we have of the line that we are looking for, which is perpendicular to L and passes through A, and we'll come to that in a second, is so far y is equal to minus 3 over 4 x plus c. All that is needed now is to find what the value of c is, and you do that by substituting the point A. Why? Because the point A passes through this line, as it mentions in the question. Okay, so we are going to sub A 3 minus 5 into this. So our y is going to be minus 5 is equal to 3 over 4, and our x is going to be 3 plus c. And this is a calculator paper, so do bear this in mind. You don't have to do this without a calculator. Okay, so you have minus 5 is equal to minus 9 over 4 plus c. And if you take the minus 9 over 4 over to this side, you should get c is equal to minus 11 over 4. So the full equation is y is equal to minus 3 over 4x minus 11 over 4. And that is the equation of the straight line that is perpendicular to L and passes through A. Okay, I'll just have a quick read of the comments. If there's any questions that anyone has. Okay, all right. Right, so let's move over to the following question, question number 17. Now, this is where it really starts to get quite complicated, so I really need you guys paying attention and making sure that you try to read the question at least twice before you move on. Because part of answering questions is that you actually understand the question. Just because a question has things like, in this case, a ratio, it doesn't necessarily mean that's all you'll be using. Sometimes you'll be using other topics involved. Okay, so let's have a read of this question together. There are some small cubes and some large cubes in a bag. The cubes are red or the cubes are yellow. The ratio of the number of small cubes to the number of large cubes is 4 to 7. Okay, that's very important. And the ratio of the number of red cubes to the number of yellow cubes is 3 to 5. Explain why the least possible number of cubes in the bag is 88. What I'll do is I'll write down what they've given me in a form that is better to understand. So let's read again. The ratio of the number of small cubes to the number of large cubes is 4 to 7. Hopefully you're back online now. Okay. You're still quite lagging, are you? Let me just have a read. Hopefully everybody is where I am. Okay, I think you're back now, so just give me a thumbs up or yes. Okay, thank you very much for confirming that, Mr. H. All right, so where was I? So we are going to write down the ratio of the number of small cubes to the number of large cubes is 4 to 7. So as I was doing it here, so S we're going to use for small, and we are going to use L for large. And underneath that, we are going to write down what the ratio is. So that's our first one right there. The second sentence, the ratio of the number of red cubes to the number of yellow cubes is 3 to 5. So again, we'll write that with in a way that we understand. So red for R is red and yellow, and we'll have 3 to 5. Okay, that's much better to understand. So let's go and read the question, the actual question, what it wants us to do. It wants us to explain why the least possible number of cubes in the bag is 88. Right. Now, if you are familiar with ratios, you should know that ratios are always expressed in their simplest forms. That means these two values right there, they could be bigger than that. For example, they could be multiplied by 2, giving us something like 8 to 14. And they can continue being multiplied to give us larger values. So this one, if we were to multiply by 2, we'll get 6 to 10. If we multiply by 2 again, for both of these, we will get 16 and 28. We'll get 12 to 20. Okay, now this is quite significant, 88. We want to find out how much we can multiply both of these by. Remember, we have to do what we do to the first ratio to the second ratio as well. Now, if you look at this, you can actually multiply both of them by each other's parts. So this one has a total of 11 parts. 4 plus 7 is 11. This one has a total of 8 parts. 3 plus 5 is 8. So if they have those respective parts for themselves, so this has 11 parts. If I could just write this here. And this one has 8 parts. If we do 11 times 8, we get 88. So 88 is the least number of cubes in the bag. And you could give some explanation like these are all simplified ratios, and you could write down this, okay, meaning that the ratios could get more and more. Okay, so that's this part of the question done. The second part of the question is a lot more trickier. It says all the cubes are yellow. So all the cubes, all the small cubes, are yellow. Work out the least possible number of large yellow cubes in the bag. So where do we begin with this? So we had earlier on all of our ratios written down in its simplest form. So we had S and L as 4 and 7. We had R and Y as 3 to 5. And when we multiply, we can get the least number of possible cubes is 88. So what do we need to multiply by to get 88? So we can have this one multiplied by 8. So therefore, if we multiply the 4 by 8, we get 32. And 7 times 8 is 56. So this gives 88 parts. Okay, so we are going to work with the minimum. Okay, and likewise, this one here, we will multiply by 11. Okay, so 3 times by 11 it gives us 33. And 5 times by 11 is 55. Once again, we have 88 parts. Or in fact, I shouldn't really use parts. Let's use cubes, because that's what they are. Okay, so they have 88 cubes in each one. Now, if they say that the small cubes, all of the small cubes are yellow, that means all the small cubes are in the bag, the 32 of them, all 32 of them are all yellow. So 32 small cubes are all yellow. How many yellow cubes are there in total in the bag? Well, yellow is represented by the 55. So there are 55 yellow cubes in the bag. So if we subtract from 55 the 32 small cubes, which we know are all yellow, we get a total of 23. That means there are 23 cubes which are yellow and they are all large. And that is the least possible number of large yellow cubes in the bag. Hopefully you understood that. I'll just quickly read all the comments if there's anything that you have as a question. Okay, nobody. Okay, right. So hopefully this does make sense. Remember, you can go back and look at the live again. It will be available on the channel. So if there's something that you need more help with or anything like that, then you can go back and have a look at this live. Okay. Let's move on to question number 18. Okay, circle theorems are always a favorite. The last 2 videos that I released on the channel were for circle theorems. There is one more video that is to be released that looks at grade 8 plus questions. Okay, now this particular question is actually one of the easier circle theorem questions. The grade 8 plus questions are circle theorems that use things like algebra with them. Okay, so do keep an eye out on the channel for that video, which will explore the higher grade circle theorem questions. Okay, So let's have a look at this. If you want to make a quick diagram of this shape, then Streamlabs, and I'm using Notability as well. And I did look at a quick tutorial on YouTube where someone was suggesting to use this, and so this is my first time doing it. But I will check out OBS in the future and try and work on that next one. Okay. All right. Adil Mia, are you buffering? Hopefully you should be back again, Adil. No. Okay. All right. All right. So if you can, just let me know that you can see this screen. I'm moving it up and down as well, so that brilliant. Okay, it's moving. I'm looking at recording the live on my computer as well to make sure that nobody is complaining of any streaming, and I've got you back. I'm just talking for ages, doing questions, and you can't see what's happening on my screen. All right, so let's look at this. We have a circle and we've got this triangle in there. We've got two triangles and we also have a quadrilateral right there. Okay, so you should remember this is a cyclic quadrilateral because it touches all the vertices touch the circumference. Okay, and we're given this piece of information here. Okay, but what I like to do with these questions is I go straight to the actual question. Work out the size of angle ADE. Okay, so we want to work out A to D to E. We want to work out this angle right there. So let's mark that. Okay, let's mark it. We'll come back to that. Okay, right. So where do we begin with a question like this? Okay, we have an isosceles triangle, as we have mentioned right there. How do we know this is isosceles? Because we are given these two markings right there. Okay. That means this angle here and this angle here are going to be the same. So in order to find out what this angle is, we've got the angle at the top right there, so we'll take that away from 180. Okay. Now it says you must give a reason for each stage of your working. So this is very, very important because you won't get all of the marks if you don't do this. Okay. So we have triangle ABD, which is an isosceles triangle. And in order to find out what these angles are, we're going to do 180 minus 40, and we are going to divide that by 2. And that gives us 140 minus 40 on our calculators, and then divided by 2 should give you 70 degrees. So this angle here is 70, and this angle here is also 70. And all three of those should add up to 180. Next, we have to build up to the answer. Okay, you can't straight away get to the angle that you want. Okay, so we will get there eventually. Right, now, as I mentioned, it's a cyclic quadrilateral. So this angle right here and this angle right there, they are opposite. And in a cyclic quadrilateral, we have opposite angles adding up to 180 degrees. Okay, so therefore, in order to find what angle BCD is, we are going to do 180 minus the 70, and that gives us 110 degrees. So this right here is 110 degrees. Now we will now find these two angles right there, because this triangle here is also an isosceles triangle. Why? Can you see this marking and this marking? That indicates that those two lengths are the same. Okay, so we'll again use the isosceles triangle to find what these angles are. So we have 180 minus 110, which is this angle right there, and we will divide that by 2, giving us 35 degrees. So this right here is 35. This is also 35. The final step to find what angle D is we are going to use this. This is a straight line, and the angles on a straight line add up to 180. So we'll write this down here. We'll say angles on a straight line, and we know that they add up to 180. So we're going to do 180 minus, in a bracket, 70 plus the 35. So 70 plus 35, and that gives us, let's just get my calculator, so 180, okay, and that gives us 75 degrees. So the angle A to D to E is 75 degrees. And that is our answer. Okay, hopefully you're still there. And I'm just going to read the comments if there's anything that I need to readdress. Okay, brilliant. Everything seems good. So we have two more questions to go, and then I'll take any questions that you may have for anything like that, for revision tips or anything like that. Okay. So question number 19. We have a triangular prism, and we are told that the base ABCD of the prism is a square of side length 15 centimeters. The angle ABE and the angle CBE are right angles. Angle EAB is 35 degrees. M is the point on DA such that D2M and M2A is in the ratio 2 to 3. Calculate the size of the angle between EM and the base of the prism. Now, this was quite a mouthful. It does look quite difficult, but we will build upon this. We will take everything that they've told us in the question and we'll note this down. Okay, so let's start off by looking at the fact that we have a point M on the line D to A. So let's mark that. So the point M, and we are told that this is in the ratio 2 to 3. So D to M and M to A is in the ratio 2 to 3. So if we take a point right there, for example, let's call this our M, and we are told that from D to M is 2 parts and M to A is 3 parts. Okay, so that's that. That's step number 1. We are also told to find the size of the angle between E to M. So we need to also draw this line in. So let's do that. So E to M. Okay, there's E to M. And the base of the prism. Now the base of the prism is this. That's the base. So in order to form a triangle so that we can have an angle, we will go from the point M all the way to the point B. And so this is the angle that we are being asked to find. Okay, so let me just use another color to mark this. This is the angle that we want to find. Okay, that's our mission. Right, so where do we begin? We do have a right angle here, by the way. Now there are several right angles here, but the one I'm forming is between EB and the base M, or the line M to B. All right, so what I like to do with these questions is I like to draw out the triangle that I'm looking at separately. So this is point M. So what I'm doing is here, I'm going to draw this triangle out separately. Okay, so that's the point M. This is the point B. We have the right angle right there, and that's E. And then I like to write down what I know and what I don't know. So I'm trying to find out this angle right there. Okay, so in order to find an angle, I'm going to be using trigonometry. But I don't have any of the sides. I don't have this side right there, which is represented here, nor do I have this side right there, which is represented right there. However, if you look at this, we have another right angle triangle, the right angle being right there. So we can look at that triangle and work out a side that we are looking for. So if I draw this out separately, so this is A, so this is A right there. This is going to be B, and this is our right angle, and this is M. Now, we know that M to A is 3 out of the total right there, which is 5 parts. So I will write down right here 3 out of the 5 of 15. Okay, because we know that this length here is 15 centimeters. So if we do that calculation right here before we proceed, so 3 over 5 times by 15, so we could do 15 divided by 5, and then times by 3. 15 divided by 5 is 3, 3 times 3 is 9, so that's 9 centimeters right there. Okay, and B to A is given to us in the question. It's told right there, so that's 15 centimeters, and there we have it. Now the length we are looking for right now is going to be here. okay, which is represented right there. Okay, that's the length that we are looking for. So what do we use for this? We have a right angle triangle and we have two sides, and we need to find the third side. We use Pythagoras' theorem. So let's label our triangle. So this is the hypotenuse, which is always opposite the right angle. And in fact, sorry, I shouldn't be saying hypotenuse. I should be using the Pythagoras symbol, which is C. And this side here, we can call it A, and this side here, we can call it B. So we want to find C. So we know Pythagoras' theorem is A squared plus B squared is equal to C squared. So A is 9, so 9 squared, plus B, which is 15, so 15 squared, is equal to X squared, because that's what we've labelled our side. 9 squared plus 15 squared, so that's going to be 81 plus, I think it's 225. You could do this on your calculator, you don't have to do this. So if we add this together, you get 81 plus 225, which is 306, is equal to X squared. So in order to find X, we do the square root of 306, and that gives us 17.4928 and some values. Now, one word of caution. Because you are going to be using this value of X for M to B, because this is what it represents, you can leave as many decimal places as possible, or you can even use the square root of 306 as your answer. If you do choose to round, just bear in mind, so if you do round this value 17.49 to maybe one decimal place, giving you 17.5, do bear in mind that will have a knock-on effect on your answer. It shouldn't matter too much, okay, but you know, your answers may differ from someone else's answer for that reason. All right, so let's put down what we have just found in our main diagram up here. So this is 17.49, so we can just round it to 17.5, okay, with that in mind. So remember, this will have a little bit of an influence on my final answer. Now, I want to find E to B, okay? I don't have E to B, so how do I find E to B? If I go back to the main diagram again, I've got E, B, A, and that is another right angle triangle that is formed. So if I draw this diagram out, so E to B to A, that's 15. We know that this is 35 because it's given to us in the diagram, and we are trying to find this side right here, which we can label as Y. What do I use to find Y? I've got a length of 15 centimeters, I've got an angle of 35 degrees, I can use trigonometry. So in order to use trigonometry, we will label our triangle according to the trigonometric identities. So opposite the angle is our Y, which we will call the op side. Adjacent to the 35 degree angle is 15 centimeters, so we'll call that edge. And the hypotenuse we have, but we don't need to work with that and worry about that right now. So opposite and adjacent. If you write down SOCAR TOA, what uses opposite and adjacent? Again, I do have a video on this, so you can see this and see some of the basic questions being applied. But we have to use tan. So tan theta, so theta we know is 35, is equal to opposite, which is our Y, over our adjacent, which is 15. If we rearrange this in terms of Y, we have 15 times by tan 35. And if you knock this into your calculator, you should get 10.503, so on and so forth. Again, you could round this to something like 10.5 to one decimal place, so centimeters. Now, let's go back to our diagram that we were working all of this for. So this Y value is E to B, so we have 10.5 centimeters. And now we are ready to answer the actual question that is asked us to find the angle for. Okay, so again, we will label our triangle according to Pythagoras' theorem, and we don't really need to do too much because it's similar to the one that we were just using. So this is adjacent, this is opposite, and we want to find this angle. So this time we'll have tan theta, because theta is unknown, is equal to opposite, which is 10.5 over 17.5. And when we are finding angles, we use the inverse. So in this case, the inverse of tan. So on your calculator, you will have to press shift to get this. Okay, so that's what we have. So let's work this out now. So inverse of tan, you can put the fraction buttons in. Make sure you're in degrees mode as well. So if your calculator's been used by an older brother or sister, they may have been using it for A-levels. Sometimes they may leave over 17.5, and we get an answer of 30.9637, so on and so forth. Now the question says, give your answer correct to one decimal place. So this is very, very tricky, maybe, okay, for some of you. So you can see that we've got 30.96. Now, to get one decimal place, that 6 will have a knock-on effect on the 9, okay? So the 6 will make the 9 into a 10. That 10 will end up making the 0 in the 30 1. So you get an answer of 31. But because the question says give your answer to one decimal place, it is important that you actually add the 0.0 degrees, okay? If you don't, and if you just leave your answer at 31, the examiner may not give you the full marks. So this is very, very important, guys, okay? All right, and that is the answer to this question. Now, I'm just going to quickly have a read of any comments. It's a free version. All right, on to our final question, question number 20. All right, hopefully so far you've been understanding. If there's anything that you don't understand, please do write in the comments section. At the end of this lesson, I will have a look at through those comments and try to answer as many of your questions as I can, okay? Now, for this next question, I do have a video on vectors. It was one of my earlier videos. So part A of this question is relatively straightforward. You should be able to whiz through that. The part B of these questions, I did try to look at some of those on my video. I can't remember if I did parts of a line or parts of a vector. If not, I will do a future video where I cover that in more detail. But I think I did do one, okay? So you should be okay with that. All right, so let's have a read of this question. This question was a tricky one. So when this paper was released in 2019, many students came out the exam quite distressed because of this particular question. So this question uses several topics. Okay, it uses most of the content of vectors, and it also uses algebra. Okay, and so you really need to write down very, very good notes. If you are a middle student, then make sure that you pick up as many marks from these questions as possible. There's a total of 6 marks, so it's quite significant. It's a significant question. It can be, half a grade or more, contributing to your final grade. Okay, right. So let's have a read. We have C, D, E, F is a quadrilateral, and C to D is A, D to E is B, and F to C is A minus B. All right. So let's mark those things in right now. So we are told that C to D is A. So C to D is A. So let's write this right there. We are told that D to E is B. So right here, all the way is B. And we are told that F to C is A minus B. Express FE in terms of A and or B, giving your answer in its simplest form. So what is FE? Let's write this down, F to E. So we want to go from F all the way to E. But we can't use this route, okay, because there's no information about going from there to there. So we have to go round. We have to go from there to there to there to there. So we have to go F to C, C to D, and D to E. That's the route that we're going to use. So F to C plus C to D plus D to E. So what's F to C? Well, F to C is given to us in our question. It's A minus B. And C to D is just A, so plus A. And D to E is B, so plus B. And now we can just collect all the like terms. So we have A plus A, which is 2A. And the minus B plus B, they cancel out. So it's just... That was the easy part of a vectors question. All vectors questions are always going to have a part A and a part B, and sometimes even a part C. Part A is always relatively quite straightforward. So make sure that you bank those 2 marks or however many marks are given for part A. The next part, I really need you guys to focus. All right, it's very important, this next part, because it is not straightforward. Okay, I didn't say it's difficult. It's just not straightforward. I remember looking at this question with a few of the teachers I work with, and even we couldn't get to the answer straight away. It did take us a bit of time, a bit of thinking. All right. So this is something that you need to bear in mind. You know, it's not always that often students start panicking because they don't understand a question straight away. Thinking that there's this expectation that they have to understand it. Okay. No. Some questions are tricky and they do require several readings of the question and several diagrams, okay, to understand this. So let's begin. M is the midpoint of D to E. So here's M right there. It's the midpoint of D to E. Now, earlier on, we were told that D to E is equal to B. So therefore, what we can now write down is that D to M would be half of B. Okay, and M to E would also be half B, giving us the full B. Okay, sorry, not D to M, M to E will be half B. Okay, so that's that. That's what we do with the information, that M is the midpoint of D to E. Next, we are told that X is the point on F to M such that F to X and X to M is in the ratio n to 1. What this means is the following, that F to X and X to M is in the ratio of n to 1. So therefore, F to M, the total of that, the total of this is n plus 1. That's F to M. Okay, the total. This is not the actual root, by the way. This is just the total part of it. Okay, that's the part of it. All right, this is something that we really need to understand going forward, because I'm going to be using this n plus 1 in the question. All right. So what else are we told? We are told that CXE is a straight line. So let's write that in. CXE. So C to X to E is a straight line. That's all we are told. Okay, nothing else. Work out the value of n. That's our mission. That's our question. So where do we begin with a question like this? Where do we begin? I'm going to zoom out a little bit because I need more writing space. Okay, and this will create a little bit more writing space for me, because I want you to see the diagram at the top and also see all of the working out that I will do. All right. Okay, let's pick a nice color for this question. Let's pick this tan brown. All right, so let's start off by calculating. In fact, before we actually do that, what is it? How do you prove a question like this? How do you answer a question like this? You see, the important part of this question is this CXE as well. This is what's going to help us. If something is a straight line, okay, CX is going to be a part of C to E. Okay, hopefully you understand what I've just said there. So if something is a straight line, so C to X is going to be a part of all of that. Or what we can do is we can say something like F to X is a part of F all the way to F to M. Okay. If you don't understand, as I'm doing the explanation, as I'm writing down the solutions for this, I will keep referring back to this so that you can begin to understand. Okay. So, as I mentioned, C to X is a part of C to E, the full line. Okay, so if I write this as a K value, so let me just go back to this. So C to X is a part of, this is what the K represents, it's a part of C to E. All right, I will come to this and do more calculations for that in the future. So we will now first need to find what C to X is. So let's go back to our diagram at the top. So C to X is from there, oops, I went too far. C to X is from there to there. How do we get from there to there? We've got several options available to us. We can either go from there to there to there to there, or we can go from C to F and F to X, which is probably the easier route. So let's use that one. Okay, so we're going to go from C to F and F to X. All right, so what is C to F? Now C to F is A minus B, but we want to go backwards. We want to go against this arrow right here. Okay, we want to go backwards. So in order to do that, we will do minus, in bracket, A minus B, and that indicates that we are going in the opposite direction. And then we want to go from F to X. Now, earlier on, I mentioned that F to X is a fraction, is a part of the full F to M. Okay, so this is very important that I do this. So F to X is N, because N, over the total. Remember I mentioned this? The total, N plus 1. So therefore, it's going to look like this. N over N plus 1 of the full F to M. That is what represents this. Okay, so this represents F to X. Take a moment to understand this. Okay, right, what is F to M though? Okay, how do I find F to M? How do I find that? I can go from F to C to D to M to find this. Or I can go from there to there to find that. In fact, let that disappear. Hold on, let's do that again. So I can go from F to C to D to M to go from F to M. Or I can go from F to E to M. This is the second one is probably easier, so we will use that one. Okay, so we'll now find F to M. All right, and we will use F to E plus E to M. Now F to E was given to us, or we found it earlier on in the question. This is F to E. So we can add this to our diagram now, 2A. So F to E here will be 2A plus E to M. Now E to M is going backwards from this half B. Okay, from this half B, it's going backwards. So that will be minus a half B. And that will give us F to M. So what we can now do is import or export this. Oops, I went too far there. We can export that right there as FM. Okay, because that's what it represents. So let's do that. Let's get rid of all of that and export that in there. Back to the tan. So we're going to continue this calculation here. So we have minus A, I'm just going to take out the bracket here, plus B. Now why is it a plus B? Because we've got minus outside and the B is already a minus. So that will give us a plus B. Plus N over N plus 1. And in bracket, we'll now write down F to M, which is 2A minus a half B. All we now have to do is simplify what we have right there. Okay, so how do we simplify that? Well, first of all, we can expand it out if you want to. So let's do that. So let's have minus A plus B plus. Now, what does that look like? That's going to be N over N plus 1 times by 2A. So it's going to look like this. 2A, in fact, let's write it 2A in a bracket, N over N plus 1, and then we multiply it with the half B as well. So that's going to be minus 1B n over n plus 1. Now, see that 2 that was with the half b, that 2 will be right there as well because it's in the denominator for the half b. All right? So this is what we have at the moment. Next, we will factorize. Now, this factorize I'm going to do is can be quite tricky for some of you, so do pay attention. I'm going to try to show you this. I'm going to collect the a's together. This is where the a's are, and I'm also going to collect the b's together, and this is where the b's are. All right? So here we go. So I'm going to have a, and in bracket I want a minus a, so let's start with a positive. So I'll have 2n over n plus 1 minus 1. Now you may be wondering, what have I just done? Don't panic. If you have a look at this, if you were to expand this out, okay, so a multiplied with all of that, that will give you this, right? And if you were to multiply the a with the minus 1, that will give you a times minus 1, which is that. That's all I've done. I've just put this into a nice bracket by factorizing it, okay? I'm going to do the same thing with the b. So I'm going to have my plus b and this together, okay? In fact, I should include the minus because that is part of that. So here we go, plus b. Now, because the first b is positive, I can put the 1 right there. So b times 1 will give me plus b. I want a negative for this next one, so minus. It's going to be minus n over, and I'm going to expand this bracket as well for the denominator, so it's going to be 2n plus 2. Right there. Okay. Again, if you were to expand this out, so if you were to do b times 1, you will get your plus b. And if you were to do b times that entire fraction there, you will also get this as well. All right. Let's scroll up a little bit for that. Now, I will say that this is my C. Now, hopefully, right, here we go. So I will simplify all of that, and I will simplify all of that. Okay, so this is where I can go to do the next live without this lag. Okay, because this is getting too much now. All right, we are back. We just finished off this one though. All right, so we are going to simplify this fraction here and this fraction there. Okay, now how do we do that? We have the 2n over n plus 1 minus 1. Let's make that 1 have the same denominator. First of all, make it into a fraction, but have the same denominator as n plus 1. Now, earlier on, we did this on a question, okay? So it shouldn't be too difficult now. So 2n minus n plus 1 times by 1, you don't need to write that, over n plus 1. I've made the denominators the same, and I've added it. I will do the same thing for the b. So b, and I will have, I'll need to make the 1 into a fraction. So I'll put 1 over 1 and then multiply it, the 1 over 1 with 2n plus 2. So I can do this now. So I have 2n plus 2 minus n, sorry about that, let's get rid of that, all over 2n plus 2. Now I will simplify both of these. I will collect the like terms and simplify, okay? So I'll have a. 2n minus n is n, and then minus 1 will come out right there. So I'll have that. For the second one, I'll have 2n minus n, so that's just n, and then plus 2, all over 2n plus 2. And this is my simplified C2x. Let's go back and see what the question was asking us to do. So where were we? Right there. This is what we were working towards. That C2x is a part of C2e. All right? So C2x is a part of C2e. Okay? That's what we're working towards. Right? So we need to find what C2e is now, because we didn't actually calculate that. So if we go back to our diagram, how do we go from C to E? Well, the easiest way is C to D, and then from D to E. So therefore that would be A plus the B here. All right? So So that would be where I was at. So k times by, k is the part of that, okay, will be a plus b. If you expand this, you get ka plus kb. Now this is equal to c2x. So c2x was written up here earlier, so we have that right here. So we can write this together now. So we can have a n minus 1 over n plus 1 plus b n plus 2 over 2n plus 2 equal to ka plus kb. So this is the final step. As you can see, we have a here and we have a there. So the k is equal to that. And we have, for this one, the b here and the b there. So therefore the k is equal to that. Now if both k's are equal to those corresponding brackets, then that means those two brackets are equal to each other. So we can write down n minus 1 over n plus 1 is equal to n plus 2 over 2n plus 2. And all we will do now is to solve this. So we will cross multiply. So we have n minus 1 times by 2n plus 2 is equal to n plus 2 times by n plus 1. And we'll expand this bracket now. So we have 2n squared plus 2n minus 2n minus 2 for that side. And for this side, we'll have n squared plus n plus 2n plus 2. And if we simplify this, so these two will cancel. So we have 2n squared minus 2 is equal to n squared. And we'll collect those like terms. So we get 3n plus 2. We'll now take everything over to one side. So we'll take this over to that side, giving us 2n squared minus n squared, which is just n squared. We'll take the plus 3n over to this side. It's got nothing to work with here, so it will just become a minus 3n. And we'll take the plus 2 over to this side, and we've already got a negative 2 there, so it'll be minus 2 minus another 2, which will be minus 4. And because we've taken everything over to the other side, we just get left with 0 on this side. The next step is to factorize this. And it's a quadratic, so we'll have n here, we'll have n here. We want something to multiply to give us 4 and add to give minus 3. So we can have a 4 here. Oops. We can have a 4 here, and we can have a 1 there. And we want a negative 4, so it'll be a negative 4. And we're going to add 1 to give the minus 3. So we have n is equal to minus 1, or n is equal to 4. Now n can't be equal to minus 1, so therefore that's not a solution. So therefore n is equal to 4, and we have found the value of n. Now why can't n be equal to minus 1? Some of you may ask. Well, if you look back at the question, f to n, this cannot be a minus part. Okay, so that's why we have to use the positive n value. And that concludes this part of the lesson. We have covered, let me just go back to the beginning. We have covered all of the grade 7 plus questions. There are a couple of grade 6s in there as well, but we'll leave it at that. The time is coming up to 8 o'clock, so we've had a good 1 hour, 20 minutes or so. I know we've had a few lags, but I will look to do another lesson soon in the future, maybe continue going over this paper, and hopefully you guys can join in again. It was my first live, so you know, things were quite sketchy. Hopefully I will improve when we do the next one. Please do suggest to me any software that I can use to make it a bit more seamless and flow much better, much nicer. But I hope you have enjoyed it. Please do check out the channel. I'll just quickly show you how to find a top screen again. So if you go to the main Maths Coach page, if you want to find a particular topic, there are several ways you can do this. The easiest way is to click the playlist at the top, and the playlist will bring several playlists which I've created specifically for you. So if you're a GCSE student, you can see all these topics here. You got algebra topics, number topics, percentages, and you can scroll across and see more. Okay, so that's one. And if you click, for example, the algebra topic, you'll be I'm playing myself. Oops, no thanks. Right, you can see all of the topics for algebra. Okay, if you go back, you can do this for each of them. But another way, a cool way of doing this, so if you click the search button on the top. So for example, if you're searching for a particular topic and you don't know whether it's in number, algebra, geometry, statistics, whatever, you can just type it in. So for example, the vectors questions that we've just done, if you want to look for that, you can just type here vectors. Okay, press enter. Move the screen down. Right, here we go. And there you go. It brings you up with the vectors question here. So you can go straight to that and you can look at the vectors. And you can do that for every single one of them. So algebraic fractions was another one. Algebraic fractions, or just type algebra or something. And hopefully that should also do the same. And you can see all the videos that I have for algebraic fractions. Okay, so that's a nice, cool way of doing that. Okay. Thank you once again for joining me, and hopefully I will see you in a future video. Goodbye for now, guys.